All right, welcome back. And today we are going to start examining how we can prove that triangles are congruent. Okay, so earlier this week we talked about once we know that we have a congruent statement, we can make comparisons between the triangles, but we want to know how we can prove it. Okay, and there's 5 different ways we can do that. The first one, and for this, before I start, let me specify the 2 letters we're going to use today are S and A. S stands for side. So if we look here, these sides are marked up. A stands for angle. So in order to find an angle, that would be like if this arc was marked. Okay, so the angle we know is in between the 2 sides. It's where the vertex occurs, where the side is like from L to K. So the first thing I want to talk about here is side congruence postulate. This is if 3 sides of one triangle are congruent to 3 sides of a second triangle, we know the 2 triangles are congruent. Now, the reason we know that, we look here at this demonstration. This one has a side of 3, 5, and 7. Over here we have 3, 5, and 7 in the same order, and the only way these can match together, I can move them around, but if these stay the same, the only way that will match together, and I gotta move that slightly, oops. Give me a second to figure this out. There. So the only way they will match together is if it's the exact same, triangle. Okay, you see when I drag it then, they are gonna, if I get this correct, the reason they're not exactly the same is because that angle is slightly off. But as you can see, they are the exact same triangle. Okay, they match up. Now, human error is why mine are off maybe by half a millimeter or something, but they are the same triangle, and that's always going to be the case. Now, that's only when 3 sides are the same. If we look here, if 3 angles are the same, right now these sides are all the same length, and they would be congruent triangles, but look, if I shrink this, just because it still has 30, 150, 30, 150, and now it's smaller, it could fit inside of it. Or I could enlarge it, and now it's way bigger. It still has 30, 150. So angle, angle, angle does not work, but side, side, side does work. Okay, now our next type, side, angle, side. If 2 sides in the included angle, so what I mean by that, do you see how this is side, angle, side? Because it's side, angle, side. You're always going to trace around your triangle and go in order. So side, angle, side. And if that is the case, then these also have to be congruent. So once again, let me show you an example. Side, angle, side. So if we know that we have a side of 3 and 7.3 with an angle of 115 in between, I can move this around wherever I want. The only way that can form a triangle, so if I go right this, it's not a triangle. The only way it can form a triangle is if it is the exact same triangle, if it's congruent. Okay? So those 2 would be congruent. And that's the only way it can make a triangle. So if we have a triangle and we know that one side or 2 sides are congruent with the angle in between also congruent, then they have to be congruent. So that's side, angle, side. Now, if we look at this proof here, I'm not going to make you guys do proofs quite yet, but I'm going to go through this one. So we're trying to prove these triangles are congruent. Now the first thing I can mark, they didn't give us anything in writing, but if you see here, these marks, those tell us that those 2 sides are the same. So I know that segment AB is the same, is congruent to segment CD, and that is given to me. It was marked on here. Now, I also have these arrowheads. Those tell me these sides are parallel. So if they're parallel cut by this transversal, then I can conclude that this angle, angle 1 and angle 2 are congruent. And the reason angle 1 has to be congruent to angle 2, because maybe you'll see it, those are alternate interior angles. And we know alternate interior angles are congruent. Okay, this final one, AC here, that is congruent on both triangles because, so I'm going to put 2 marks there, because it is part of both triangle BAC and triangle DCA. It's a part of both. And so we can say that segment AC is congruent to segment AC. Anytime it's the same line used twice, that is going to be called our reflexive property. I believe we mentioned that before, but reflexive property tells us that it's part of both triangles. Okay, then the final thing, we can write this congruent statement because now we have a segment, angle, segment, or side, angle, side, or side, angle, side over here. So SAS will prove that those are congruent. So triangle BAC is congruent to triangle DCA, and our reason, side, angle, side. All right. Now the next one I want to talk about, angle, side, angle. This is when two angles and the included side of one triangle are congruent. And that tells us if that's the case, then these have to be congruent triangles. So ASA would be right here. Do you see how they each have an angle of 35 and 65 with a side of 7 in between? The only way this can be possible is if this third vertex ends up right there, which hopefully you can see these are congruent. Okay, our next one. Oops, wrong page. Angle, angle, side. This tells us if two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So if we look here, AAS, where this one, the side was in between those two angles, but here it's AAS versus ASA. Okay, so angle, angle, side. Now the reason these are congruent, the only way, let's see if I can get this there. Okay, the only way that these triangles can be oriented, if they have a side of 11, an angle of 57, and another angle of 43, I can move this in and out, but the only time it becomes a triangle is when it's right here, and those two would match up. Now, anytime we are dealing with S's and A's, every year when I teach this, someone wonders, why can't we have angle side sides? So pause for a minute, think about that, why that would be maybe funny. I get it, ASS, right? That'd be funny if we had to write that on the board for math class. But this model puts a SSA instead of ASS. But the reason this does not work, if we look here, if I have two sides and an angle, so ASS, angle 25, a side of 11 and a side of 6. Same thing up here, but there are two triangles that could be formed. One would be right here, and that would be congruent. I also could bring it over here, and do you see that second triangle is not congruent? So just because we have ASS, it does not prove they are the same. Now the last type, there's a special situation where this does occur if we have just one angle and two sides. So here we have an angle and two sides, but this angle is 90 degrees. If it is exactly 90 degrees, so when it's the hypotenuse leg is what this is called, because it's a hypotenuse because it's a right angle. This is the one situation where it does work. And if we look here, the only spot it could go is right there, and then those would be congruent. So if it's a right triangle, we can prove it using HL. Now, once again, we need to decide why are these triangles congruent. So our 5 different reasons, and I'll write them out here. You probably want to write these 5 down or in a list. We have SSS for side, side, side. We have SAS for side, angle, side. We have ASA for angle, side, angle. And we have AAS for angle, angle, side. And then the final one HL for hypotenuse leg. Now remember, the one we cannot have, we can't have that, okay? Angle side side does not work. Now, if we look here at this one, we right now have one side right here marked and one angle, and on the other one side and one angle. At this point, that's only two pieces of information. We need a third piece. However, right here in the middle, these are vertical angles. So I can mark those as congruent, and now if we look, I have an angle, and a side. On this one, angle, angle, side. And so we can prove this by angle, angle, side theorem. Okay, letter B here. It tells us that these two are right angles, so we know they're congruent. GJ and JI are congruent, so I can put a mark here and here. And I still may have one side and one angle. However, right here in the middle, HJ, that is congruent through the reflexive property. We know that's congruent. So if that's the case, if HJ is part of both triangles, we know it has to be congruent in both. And now we have one side, one angle, and another side. So that would be SAS. Okay, we look at this next one. We have this angle is the same as this one. This angle is the same as this one. That's only two angles, though. We need another piece of information. But from R to Q, I can put a mark because that is a reflexive property. That is the same. And now we have angle, side, angle, or angle, side, angle. Oops. All right. Then our final one here, we have two sides with an angle in between. So that's going to be side, angle, side. All right. So now the next thing I want us to do, go ahead and look over here, and we have some notes. We are trying to figure out which one for these. So once again, the same thing we did yesterday. This first one, or sorry, the same thing we just did is what I meant. This first one is just side, side, side. Three sides are the same, so we know it's side, side, side. On number 2, we could add an angle there because they're vertical. So this would be side, angle, side. On number 3, I could put a mark here because it's reflexive property. Now I have 3 sides, so side, side, side. Number 4, we've got side, angle, side. Number 5, once again, 3 sides are marked, so that'd be side, side, side. Number 6 doesn't currently have enough information, but I know EF is the same because of reflexive property. So now I have side, angle, side. Number 7, all I've got is one angle. I could add a side here because of the reflexive property, but that is not enough information. So I'm going to put NEI for not enough information. Our next one, hopefully you see it. We've got a side here, an angle, and then another side. So SAS. And then number 9 here, ASS, angle, side, side. Remember ASS, anytime you get ASS, you got a problem. That's not going to be right. Okay, so we put not enough information. Okay, so now the final thing as we think about it, this is the same concept of what we were just doing, except now I need to also establish my congruent statement. So if we look here, the reason these are congruent, all the sides are marked, so we know it's going to be by side, side, side. Now, from J to K goes over the 1 mark. So we know it has to be either X or Y first. So it's JKL goes over 1, then over 2, then over 3. So we got to follow the same pattern. So it's going to be X, Y, Z. So triangle X, Y, Z. Now on this next one, we have side, angle, side. This one's a little easier because we know the angles have to match up. So we know P and D have to match up. So D has to go in the middle. Now it's RP. So RP is over the 2. So we know ours has to be FDE. So this will be by triangle FDE. Okay, then that was SSS and SAS. We also have our 2 other types, ASA and AAS. So if we look at number 3, we've got an angle, a side, and an angle. Now this one should hopefully be easy because JKL, J is the one that's not marked, so P has to go first. Then K is the one with 1 arc, so M, and L has 2 arcs on both sides. So it'll be PML. And order does matter in our congruent statements. All right, this last one on this side, angle, angle, side. So if we look here, it's from D, H, E. It has to start at G, and then it's going to be GFE. So triangle GFE. So I know this lesson's a little longer, but I want to finish up with a few more. So if I were you, I recommend you pause this and you try these 4. You don't need to draw them all out, but try to see if you can write it down. Number 5 here, so DAM. We have an angle, another angle, and a side. So this is by AAS, angle, angle, side. And it goes D to A to M. So ours will have to go from C to B to M. All right, if you aren't understanding this, I recommend we might need some extra help. That's fine. Join my office hours and I can help you out. If you need any help, also you can send me an email. So on this next one, we have a side, an angle, and a side on both of them. So that'll be SAS and CAB. CA goes over the double, so it has to be FED. All right, here we have 3 sides that are marked on both, so that's by SSS. So we have to be careful if it's ABC. So ABC, that's 1, then 3. So it'll be over 1, then over 3. So it has to be EFD. And then here, this final one, we've got an angle, a side, and an angle. And it was ECD. So ECD down here will have to be EAB. All right. So to wrap it up real quick, we'll just identify how we can identify that these are the same. So this first one only has 2 things, but JM by the reflexive property we can mark because it's part of both triangles. So that'd be SSS. Okay, once again, reflexive property allows us to mark PQ. It's part of both triangles. So now we have SAS. On this one, I can mark in the middle here because those are vertical angles. So now I have ASA. On number 12, I can mark FH because it is a reflexive property. It's part of both triangles. So that's SSS for us. Number 13, once again, we've got vertical angles here. And now we have SAS. And our final one, number 14, I have an angles. This middle side is part of both, so reflexive property. That would be ASA. So kind of a lot to take in. This was one of the more challenging lessons this year. If you need help, please reach out. But hope you guys have a great day.